So hello YouTube, this is a video on SolidWorks static simulation. I have already made a video on SolidWorks static simulation where I applied force onto a beam. Now this simulation is about the torque. So what is torque? Torque is a force which acts onto the circular elements like nut bolt, shaft, sprocket, gears. Okay. So it is also a very important kind of simulation. I have already covered a video on the dynamic simulation also. So this video is going to be on the torque simulation. So let's start. Click on part, click on OK. Okay. Then change the unit to mmgs. Click on right plane, sketch, click on circle, choose a circle, give the dimension 200. Go to features, extrude, keep it 50, click on OK. Okay, again click on this front plane, sketch, again click on circle, choose the circle dimension to be 160, exit, make the circle as a construction geometry, choose the topmost quadrant, draw a circle of 20 diameter. Okay, now features, extrude, cut, and keep the condition through all both. Click onto the feature, go to the circular pattern, choose this face, keep 9 numbers, equal distancing, and click on OK. Now just save the part, I'll name it as 1, save, OK. Now just go to create a new part again. Again change the unit to mmgs, click on right plane, sketch, make a circle, give the diameter 200. Again go to features, extrude, this time keep it 10 only. Again go to features, again choose this plane, sketch, make a circle of diameter 160. Choose the circle, make it a construction geometry, and make a circle at the topmost quadrant of 20 diameter. Features, extrude, cut, and again keep the condition true all. Now again choose the extrude cut feature, go to the circular pattern, choose this face, keep 9 numbers, and click on OK. Okay, before saving, again click on this face. Now here we'll draw a shaft. Take a circle, keep the diameter 60, go to features, extrude, and extrude it. Okay, like this much. Okay, it should be it should be looking like this much. You can also take see what is the dimension. Okay, so keep it 230. Okay, now just at whatever location you want. Now again go and we will now create an assembly. Choose both of the parts and insert them. So see, this is first component and this is your second component. Now go to the mate, choose this face and this face. Click on concentric. Okay, and then choose this face and this face and choose coincident mate. Click on OK. Okay, so this is a shaft which is rotating shaft. But now we want to apply the fixed support. Okay, so for fixed support, we want these holes of the back part and this part to be to match with one another. Okay, to be concentric. So what we'll do, again choose mate, choose this circle and this circle. Okay, and they will be concentric then. Okay, so see, we have made the assembly. Now I will also explain you the design features. So here go to design, then here choose toolbox. In the toolbox, choose ANSI metric. Here choose bolt and screw. Here choose hex screw. Now just zoom onto one of the part and just drag the screw at the hole. Okay, and then change the dimension to M20 because the whole diameter that we are taking is a 20, right? Okay, then delete this. I inserted one more by mistake. Now again choose mate. Select this face and this face and choose coincident mate. Click on OK. So now what we'll do is we'll just mirror this component. So choose that, sorry, mirror, we will just circular pattern this component. So choose that component, go here, choose circular pattern. In direction, choose this face, and the degree is 360 divided by 9 because there are 9 holes, and the number is also 9. And click on OK. So see, but now if you want to apply the fixed support, we'll have to hide this screw. Okay, these nuts. So what we'll do, just right click, click on hide, and on the circular pattern, right click and click on the suppress. So see. Okay, so this is the geometry. Now for simulation, go on to add-ins, click on SolidWorks simulation. It will take 3 to 4 seconds for this tab to appear, the simulation tab. Click onto the simulation tab, go to new study, and here choose static. Now we will not check onto the use 2D simplification. What is 2D simplification? I have already covered in the previous video. 2D simplification is used only when the geometry is symmetric over a plane. Now this, because it is a circular geometry, is not symmetric over any of the plane, neither front, top, or right plane. Okay, so here we will not be able to use 2D simplification. So just click onto the static and click on OK. Now the first step is to apply material. So just go into apply material. I will apply alloy steel to both of the part. Okay, then close. So see, this is alloy steel. Now we'll go to fixture, go to fixed geometry. And so if this is a shaft which is coupled to this bush-like structure, then where will be the fixed geometry? So the fixed geometry will be at the points of the what I can say, the bolt points. Okay, so here it is a bolt point. So we'll have to individually select all the holes. Okay, because we cannot select feature as a fixed geometry. We'll have to select faces only. So individually select all of the faces. We'll also vary the material. We'll vary all the end conditions, boundary conditions that we are providing, and we'll see how the results vary accordingly. Okay, so this is the fixed support. Fixed support is indicated by a green arrow. Then go on to external load, right click onto torque. Choose this face and also choose the axis. For axis, we'll select this circular face. Okay, so see, it is showing direction. You can also change the direction to reverse direction if you want. Now the Newton meter torque we are going to keep is 5000. Okay, click on to OK. See, it is a 5000 Newton meter torque. Now right click onto the mesh, click on create mesh. Okay, you can use fine mesh if you want. I'm using a coarse mesh only. Okay, so see, this is the meshed geometry. Now the final step is to click on to the run the study. Now the time specification. So see, this is the it will give you the result in the form of stress, displacement, and strain. Now, if you click on the displacement, you can see the shaft bulging outside. Why this is happening? Because we have provided fixed support over here, and we have provided torque in a rotating direction, okay, clockwise. And because of this, in real life, what will happen is because of if suddenly a shaft stops, maximum forces will be generated, and the shaft will bulge outside because of the centrifugal force. So that is why it is showing this bulging of the shaft. Now the bulging of the shaft is very low. If you want to see the values, you will just right click on here, go to chart option, and here choose floating. Okay, so see, the red part where maximum displacement is occurring is only of 0.1 mm. Okay, only 0.1 mm, that is 10% of 1 mm. So that is very less. Then why it is showing that much of bulginess over here? This is for our visualization. Okay, because if it could have not been scaled the results, it would have been very difficult for us to visualize, right? So SolidWorks has scaled the result for us. So if you want to know how much it has scaled the result, you can see over here. So they are saying deformation scale is 162. So they have just multiplied this deformation 0.1 into 162 to show us the result. If you want to see at a true scale, that is 1:1, just uncheck onto the deformed results. So see, okay. Now why they use the why they scale the results, that is also because it helps into the animation. So if you again click on to deformed result, and now if you click on to animate, so see, this is the animation. So for the animation to be better visualization, they increase the scale accordingly. Okay, so now we'll just vary our conditions a little. We'll not change the material, we'll just vary the, for example, if we right click on the torque, now we applied the torque only on this face. Suppose because this entire geometry is one geometry, so I should have selected all the faces. So I will select this face also and this face also. Okay, and now we'll click OK. And if you want to visualize the factor of safety, so I will also show you how to visualize factor. Before the spaces were generated only at this edge, but because now we are applied force at this also and this also, torque at this face and this face also, the results are also taking place over here. If you want to see the factor of safety, just right click on result and click on define factor of safety. The factor of safety for this is found to be 2.5. Okay, so 2.5 is good factor of safety. The factor of safety should always be greater than 1 for the geometry to be safe. Okay, so now we'll just increase the torque. So suppose if I take here 2123, that is 20,000. Okay, and now if I rerun the study, let's see what's the result. See, so the stresses have increased, and now if you go to the factor of safety, see, the factor of safety is found to be 0.6. That is, this is not safe in a real life condition. Okay, and stresses will be generated at what points? Stresses will be generated, maximum stress will be generated at this point. Okay, so now if you want to see how, see, they're giving you what is the yield strength. Okay, they're showing you. So if you want to see this in the floating number, click on the chart option, go to scientific, click on floating, click on OK. So see, now they're also saying 3 decimal points. So we don't want to see 3 decimal point. Again, go to chart option, and here change the decimal point to 0. Okay, so how many digit number is this? 1, 2, 3, 4, 5, 6, 7, 8, 9 digit number starting with a 9. And the maximum strength is also a 9 digit number, but it is starting with a 6. So the maximum stress generated is more than that of the yield strength of the material. So this is not a safe geometry. Okay, or this is not a safe condition for the given material. So what we'll do is we'll just reduce the Newton meter torque. We'll make it 10, 1, 2, 3. Okay, 10,000. And again rerun the study. Factor of safety. See, now the factor of safety is found to be 1.3. And now if you go to stresses, see, it is again a 9 digit number, but it is starting with 4. Previously it was starting with 9. So now it is safer than the, so the maximum stress generated is less than the maximum yield strength of the material. Okay, so this is a safe geometry. You can also animate your result if you want. Suppose if I click on displacement, go to animation. See, now it is showing at only 5 frames per second, so it is a bit laggy. So click on stop, change this to 40 frames, and again click on run. It will recalculate all the frames, and then you will be able to visualize. You can also increase the speed if you want. So see, it's pretty smooth now, right? Suppose if you want to hide all these arrows, okay, the conditions of the fixed support and torque that you provided, just click on torque and click on hide. Okay, right click on the fixed support and hide. See, now you can visualize the results properly. So this is all about the torque analysis. I hope you would have learned something out of this video, and whoever watched till end, thanks a lot. And I will also provide the new videos on the SolidWorks, okay, on simulation, on part design, animation, assembly, okay, piping, routing. So I'm making videos on all types of features of the SolidWorks, and I will also make videos on the other softwares like NX, Solid Edge, Fusion 360. So do stay tuned. Okay, thanks a lot.